sir, does Berkeley have a merry-go-round? How many of you know what a merry-go-round is? You go round, round, round till you puke. You've been on them before? He said, no, we don't have a merry-go-round at Berkeley. I said, you ought to get one, man. You could learn some good science on a merry-go-round. If you put some fourth graders on a merry-go-round, are there any fourth graders in here this morning? Oh, man, all right. I like fourth graders. I spent the best 5 years of my life in the fourth grade. That was before they diagnosed ADD. We're going to put some fourth graders on the merry-go-round and get the high school football team out there to get it spinning clockwise as fast as it will possibly go. Now, if you have a digital watch, you may not know what clockwise means. Never mind. I'll explain it later. We're going to spin the merry-go-round clockwise. The kids are going to go through 4 phases. They start off in phase 1. They're screaming at the football players. Come on, let's go. Faster, faster. Can't you go any faster? You get up around 30 miles an hour. The kids enter phase 2, where they stop screaming. They just quietly concentrate on trying to hang on for dear life. You get up around 60 miles an hour. The kids enter phase 3, where they start screaming again. But now they're screaming, stop, stop, please slow down. Don't stop, though. Keep going faster and faster. When you get to about 100 miles an hour, the kids enter phase 4. That's where they begin to fly off the merry-go-round. Now, if you watch this carefully, if the kids fly off the merry-go-round, and the merry-go-round is going clockwise, when the kid flies off, the kid will be spinning clockwise until he encounters resistance, like a tree or telephone pole. That's because of a law in physics known as the conservation of angular momentum. You see, if a spinning object breaks apart in a frictionless environment, which is what the Big Bang would have been, all the matter in one spot, no friction, the pieces that fly off are going to spin the same direction as the original object because the outside is moving faster than the inside. And we could talk all day about the Big Bang theory and the conservation of all sorts of problems within our own solar system for the conservation of angular momentum. But the professor said, yes, I understand about the conservation of angular momentum. I said, well, good. Then would you answer me just one question? If the universe began as a swirling dot, shouldn't everything be spinning the same way? He said, yes. I said, well, did you know that 2, maybe 3 of the planets are spinning backwards? Did you know that 8 of the 91 known moons are spinning backwards? Sir, did you know some of the whole galaxies are spinning backwards? Why? He said, that's interesting. I said, no, sir, that's more than interesting. That's kind of hard on your Big Bang theory. He said, why do you think they're going backwards? I was hoping he was going to ask that. I said, sir, it's very simple. You see, in the beginning, God created the heaven and the earth. And God did it that way on purpose, just to make the Big Bang theory look stupid. And it is stupid, okay?
Hello, I'm Gav.
I'm Dan.
And this is the slowest Slow-Mo Guys video we've ever done.
Pretty interesting. We're going to spin a CD literally at warp speed. So it's going to go so fast around and around, it's going to start warping.
Warp 1.
Warp 1, and then it's going to break and shatter into lots of different pieces.
The critical spin rate of a CD is 23,000 RPM. Hopefully we'll be able to achieve that and film it at 28,500 frames a second. Let's look at what we got.
All right. You can see it warping. Look at that. Whoa. It's moving so much.
Oh my god.
Look at the shape of it. It's moving, like the whole thing.
Whoa! My god!
Oh man.
That looks amazing!
Literally just shattered into tiny little bits.
It's just like physics don't know what to do and the CD's just like, nope,
No,
I'm gone.
I'm out. I'm done.
Oh, that's amazing!
See that again?
I've seen that at lower speeds. I've never seen it so clear.
What frame rate was that?
28,500.
28,000 frames a second. And the cracks in it were perfectly like the direction the CD was spinning. It was like a spiral effect on the CD. Like a turbine. That was cool. Wow, that's cool. That is amazing. That's wicked. That is amazing. It goes like either side of the middle hole, doesn't it? Like it follows the shape of the CD and then finally meets up again at the other side. Side view of the warp speed. Oh my
what is happening?
Look at that! It doesn't even look like a CD anymore. Oh, that's amazing.
It's so bent. It's spinning like at a different speed, so it's warp.
That's amazing. The warp just seems to be staying there while the CD spins further and further around, almost like the air is pushing it. It looks like.
That's
crazy.
ridiculous.
It's like it's trying to take off. That's awesome.
You can see why it gives out.
Yeah.
That is some force. I would have thought that the warp would have gone around with the disc, if you know what I mean.
Yeah, yeah.
Alright, here's the moment of impact. Oy!
See you later.
Oh, all the bits that hit the vice just exploded.
Oh man, it got pulverized.
Yeah. Solid. Well, thanks very much for watching that video. Be sure to follow us on Twitter. Buy a shirt if you want. We sell shirts, who would have thought? And subscribe to the Slow Mo Guys.